Welcome, everyone. I guess you're slowly connecting to this webinar. So welcome. Take a seat, take some water. So we started a bit earlier than expected, to be honest, to let you take your seat and grab a coffee. We will officially start in a few minutes at, as expected, at 4 p.m. CST, sorry, European time. So if you're here, there's the chat. Just drop maybe a note saying where you connected from. That would be cool. So I'm currently connected from south of France, Marseille, close to Marseille. And Antonio, where are you connected today? Where are you connected?
Today I'm in Madrid. Hopefully tomorrow as well. Yeah. Maybe if we had this talk months ago, I would say that I was in Bratislava. I used to live in Bratislava, and Spaniard in Bratislava, Central Europe. So that's difficult to find. Yeah, I'm back to my roots, so I'm now in Madrid, in Spain.
So how is the weather in Madrid, by the way? Because here, I don't know for I mean most of the Europeans in the north at least, the temperature dropped heavily, and here it's okay-ish. I still have shorts, but I guess in few days or few weeks I may have to put some pants. But what about you?
Maybe finally autumn comes, because so far we only had summer.
Yeah, something.
Like 3 days ago, it was like 30 degrees still. Everybody on swimming suit.
Yeah,
it was
we had 29,
really
27.
crazy. But
yeah,
honestly, I'm gonna be totally honest here. Coming from a cold country like Slovakia, I'd really like to have just plenty of sun over the whole year. So that sounds very selfish, but let's say yes. Come on. I really love the summertime, hot temperatures. So yeah, don't you prefer that?
Yeah, sure. I love it. I mean, that's if otherwise I won't be living here in south of France. So we have people from Italy. So hi from Italy. Also have Netherlands, where it's quite chilly. It seems so. So Mark, autumn is coming. I'm sorry. Oh, you have Jonah. Hey, Jonah, how are you? Good to see you. I mean, good to see you. I'm not seeing you, but I can see that you're connected. So cool. And yeah, another attendee from Netherlands. So a lot of people from the Netherlands. Nobody's from France. Or do we have any people connected from France or from Portugal or from Germany? Or
I see from Spain. Yeah.
Yeah, I see that.
Italy, Andrea. I see some names that rings a bell. Hi guys. Maybe later we have a call. Netherlands, not for France. Germany. Anybody joining from Germany?
Or from the UK, or even if you're connected from early morning and from the US, that would be also cool to know that. So we have 1 minute to go before we start. So again, I'm preparing my drink, so you can do the same. But yeah, there will be a lot of content. I actually enjoyed preparing that event with Antonio. A lot of fun. So we'll see. I hope that you will have fun. I hope you will learn something out of this webinar. But it was fun to prepare it. So we'll see. I'm not revealing anything. Oh, it's top of the hour. So Antonio, are you ready to roll out?
Let's do it.
All right, let's go. So welcome everyone to this webinar, joint webinar between Dynatrace from my end and from solo.io. So today we're going to talk about enhancing Kubernetes workload, how to become the Jedi master of traffic management with Dynatrace and solo.io. So let me introduce myself, and I will let Antonio do the same thing. So my name is Henrik Rexed. I'm a cloud native advocate working at Dynatrace a bit less than 3 years now. But otherwise, I've been spent all my career doing performance engineering, So breaking things, tuning things, optimizing things, that was my day-to-day job. And that's why I'm still love that practice. So there's a YouTube channel, or it used to be a podcast that transitioned to a YouTube channel called Perf Bytes. So if you're working in the performance engineering space, check it out on YouTube, Perf Bytes. There's a lot of content out there, and yeah, makes sense. And also it makes sense to share your feedback if you think you could be approved, of course. And the other thing that I started 2 years ago is another YouTube channel related to observability in general, and it's called Is It Observable? So it's out there again. It's a young channel, so to improve the content, I definitely need your feedback. And Antonio, how about yourself?
Well, thank you, Henry. This is Antonio from Spain. You can see here in the screen, I'm actually organizing here in Madrid with some colleagues and some friends CNCF meetups. We are called CNCF Iberia. So you are welcome if you want to join us, virtual, in place, whatever. We are very enthusiastic on trying to create community around the technologies. That is probably what we are talking here today. My background, very simple. I'm actually what also can be called field engineer, which is answering questions to customers about our product, our technology that today we are going to talk about. And just like a headline is like I'm a 12-factor believer. So many people were asking what is 12-factor. I started my career as a developer. Then I moved to DevOps, and then I ended up being architect as well in some enterprises. So I base everything on very simplistic, where the story start, the cloud native story start, the 12-factor application. I base everything about that. I just wanted to share with you guys. And yeah, let's get started, because let's not talk about us and let's tackle this.
All right, let's go. So let's we would like to tell you a story. In fact, everything is related to a story. It's a real story, in fact. So we're going to reveal any names, but we're going to share what happened. And this company is a retailer that suffered from a big disaster in production. It was during a production hour. They recovered pretty well, and no, I mean, there was at the moment it was quite stressful. So we're going to share that story, and of course, the story will be, of course, related to Kubernetes. So that's why we picked that story, and and behind the scene, it's going to be related to networking, and that's why we will have to go through the service mesh and how we could resolve this utilizing service meshes. So, as what you're going to expect from this webinar. Well, a couple of things. We're going to talk about a couple of features we've selected to avoid what happened during that day. So the request timeout is one of them. The second one is rate limit. And the last is going to be circuit breaker. Of course, we're going to cover many other features covered by the service mesh. Yeah, and I'm an observability geek and passionate. So what do you expect? I'm gonna, of course, talk about observability. So be patient, be ready, and there's a lot of content, and we will let place for Q&A. So if you have questions, just note that questions. We will just be very excited to answer to any of your questions. So let me go through this story. So once upon a time, it's a well-known retailer delivering products mostly around the globe. And this company has a very interesting payment method that they deliver in certain countries. It's called invoicing. Of course, you cannot offer that payment methods to all of your customers, because at the end, if you invoice and you don't know if the customer is reliable, it doesn't make sense. So they are providing that payment methods based on a risk service. So they are identifying if the customer has paid all the orders. It's been a customer since many years. So basically, they are evaluating the customer itself before providing that payment methods. And during that during the main disaster, what is happened is that this frame or this pop-up that allow you to pay was not displayed. So there was nothing. So it means, for imagine a retailer where or your customers is adding product in the cart, and then once they go to checkout, there's no way of paying. So I think that's quite a disaster. It was very stressful, so they lost lots of money. So you can imagine that is something that you want to avoid as much as possible, especially for this type of companies. So what happened behind the scene? So the payment methods that were uh, to display these payment methods, it was basically relied on another service called the risk-based service to evaluate how the customer, uh, the level of the customer. And the problem that we had at that moment, they had at the moment, is that this risk services was not responding anymore. In fact, technically in the background, there was an ingress rule, and when they looked at the various dashboard, they saw that there was a lot of 50x errors, and they looked deeper on those 50x, and they saw that, oh, it's a 502 bad gateway error. So that sounds like a proxy problem. So what was the initial problem? Well, the initial problem was very simple. It's ingress rule. You have different services, and the risk services were sharing the same ingress with another service or another application. And when they looked at the risk service, everything was super healthy. So the the root cause was not related to the risk, the behavior of the risk service. In fact, technically was related to the ingress that suddenly was OM killed. So first, the big question mark is, what is an OM kill? So for those who doesn't know, let me just remind and explain what is an OM kill. So the OM kill is basically it's part of the when you deploy in Kubernetes, you need to define resource informations, how much memory and CPU I need to request, and you will see the limits afterward. But the request at the end is very important because when you utilize Kubernetes, we rely on the Kubernetes scheduler, and the scheduler looks at the resources, and based on the resource definition that we have defined, he will basically identify the right node to put that workload on that location. So it's similar like Tetris. He looks at the shape, depending on the size of the shape, he will place it on the right spot to make points. Same approach. So a request is expressed in CPU, CPU is expressed in MIDI core, and memory in megabytes. On the limits side, it's basically you can request 1 gig, but nothing is limiting your workload to consume more. So I can have 1 gig as requested, but I can consume 5 gig or 6 gigs. So the idea of limit is to basically limit the fact that your application cannot consume more than the limit that you've defined. So that's, I mean, what do you expect from a limit? Of course, it's going to be this. But at the end, what happened if you're not defining well those limits, if especially in the memory side, then if you are consuming more than expected, then Kubernetes or the nodes will OM killed. So it will kill your applications and throw an OM kill event. So that happened that day. So the ingress control were over consuming memory, and at the end, it was OM killed. But the question is, how can an ingress controller consume more memory? Simple. If I'm a proxy, I serve different endpoints. If one of the endpoint is slowing down, then I have more incoming requests coming in, but the endpoint takes more time to respond. So at the end, I'm accumulating more and more requests, or more threads is accumulated on the proxy side, and at the end, more threads means more memory consumed, more CPU, and that day the risk services were behaving well, but the other service was slowing down. So bad performance at that moment. So that caused UMQ. So how can we prevent that? Well, you can say, well, interesting, but we talked about request timeout at the beginning, but where are we heading to? Yeah, come on, be patient, guys. So let me explain you guys how we can expose traffic from a Kubernetes cluster. And Antonio knows it very well, and I'm pretty sure that all of you knows it very well. But to expose services out of the cluster, of course, Ingress, we mentioned, they used Ingress. I'm going to reveal the Ingresses. But the other solution is to use a load balancer services. So the load balancer services is a service type in Kubernetes. And the problem of that is that every time you deploy load balancer services, it will allocate an external IP address. So that could be sounds quite expensive, and it won't resolve us to this problem that we were just facing. So the other solution is the Gloo platform. Using a service mesh having different features, including the ingress and egress, will basically help us to protect ourselves and avoid these critical situations. Yeah, okay. You know that. It's nothing interesting for you. I understand it. So let's cover it in a different way. So how can we avoid this? So, Antonio, do you have an idea how we can avoid this critical problem that they were facing in production?
Yeah, actually, there are quite of interesting patterns that we can discuss and discover here, and try to see if actually those could have solved that problem that these guys had. Poor operators, always, I think. Those guys that they have to work extra hours to fix those production problems, right?
Yeah, completely,
So
especially in the stress, in the middle of the stress for sure.
yeah, definitely. So let's see what if we can go to one of the patterns.
Yeah, so there's three patterns, just to explain how we're going to walk through. So the first one is we were having a service that was quite slow. So we know that slow service is going to impact other services. So let's figure out how we can limit the impact of slow services. The second thing is protect. I mean, if, for example, these services were slow because it had reached too many requests, maybe we can limit the traffic somehow. And lastly, we can also block the traffic to make sure that this traffic is unhealthy. So we want to we won't route any traffic anymore to that service. So those is typically feature implementations in service mesh. And the first one is request timeout. So Antonio, could you explain us the request timeout?
All right, so let just making it simple, two services, right? Or one client calling one service and just another service. So we have A, B, and C. Just figure that C is taking too long to process, but the request started from service A. So it's gonna take so much time that it's just consuming the resources, the capacity, the connection pool of the whole system, creating latency. Do we want that? Actually, what we want is to have control about what is happening as soon as possible. That is called fail fast. In order to do that, we can just implement request timeout, where actually we're going to say, just wait. In this case, we can see it here is a policy in our system. Just wait 2 seconds. After 2 seconds, cut the connection and then handle the error. That is the intention, to be able to fail fast, to be able to handle the error. Doesn't mean this can be retrained again, or maybe just returning some feedback with the status of the reason why the connection failed.
There is, and the second scenario is rate limit. So what is rate limit?
So rate limit is a bit different. The idea about that is we want to avoid that continuous calls, they can bring down our service. The purpose of having services is always to have business running, to offer business. So we want always to have those services up and running, to be available. If we have a client running millions, an attacker, just imagine some malicious actor running millions of requests against our service, we can understand that the service is going to come down. So rate limit, it's a pattern that we apply to block that somebody, some client, some attacker can run so many requests. In this case, as we can see here, we can define like, okay, a person cannot manually run more than 100 requests per minute. So figuring that in this scenario, it's a person, it's a human being touching and interacting with our system, is not going to be able to run more than 100. So over 100, we consider that that is going to be a malicious action. With this policy, we block that. And from that point on, you're going to be rate limited. You're going to receive an error that also can be handled, that is rate limit. Maybe
and the last one is circuit breaker.
Yeah, this one is the most interesting one. So like the definition of a circuit, and we break the circuit. Keeping the scenario of A calls B calls C, right? We have a change of requests. So what we want to achieve with this, it's like, for example, maybe in a redundant or replicant scale service, we've got some pods, some applications that they are behaving wrongly. In order to define if actually that service is available, we need to run certain requests to mark them as down or up to see if actually in effect they are available. This usually with platforms like Kubernetes, we can define health checks, but that happens internally. What we are going to test here is that the caller, again, A calling B calling C, so in this case, probably B, is checking that C is available. If any of the replicas of C is not available, we're going to mark them as down, so we're not going to never try a request against that, that replica. We only focus on the ones that they are available.
But
Does it
when
make
you
sense?
yeah, it makes sense. But when you describe it, it seems that rate limits and circuit breakers as a all very close approach, because at the end you define the maximum number of incoming traffic, whatever, and you block it in as well. So what is the difference between the rate limit and a circuit breaker?
So good point. Many people think that just trying to go rate limited, they're going to be just covered. But the problem with the rate limiter is actually we are not checking the availability. It's just a request that can always, the first one is going to be performed. So although that might think or look like we are being protected, there are requests happening that they shouldn't, because we understand already our system should be smart enough to understand that that request is going to fail. That is the purpose of the circuit breaker. We're going to know in advance the platform, the system is going to define if actually the application is available or not. If not, as we said before, we mark it.
So at the end, you remove the endpoint or the replica out of the load balancing policies. So then the traffic will never reach this endpoint anymore. So basically, it's being considered to be an out of the normal behaving of the that we have defined. So it's smarter. I think circuit breaker in some.
Let's see that case. To compare could be like being proactive or being reactive. Rate limit is being reactive, whilst circuit breaker it's being proactive.
So rate limit also is also for security aspects, where circuit breaker is more for the reliability of the system itself.
Exactly. Many people, when confuse this, they try to use rate limit in a way that probably is not the right one. We always need to understand that rate limit try to protect you for DDoS attacks, as well as WAF policies can protect you against query injection on your request. So those components are intended to be protected and in the event of an attacker, while circuit breaker is really trying to make resiliency in your system, like we mentioned before with rate limit. Those two patterns are considered part of the resiliency group of patterns to be applied in your systems in order to really, to always, as we said before, always be in green, always give business.
All right. So, but there's more than those features that a service mesh can do. And in fact, to explain it very briefly, when we build microservices architecture, there are lots of things that we have to manage. So in the past, when service mesh was not available, we had to manage the retry logic. So retry logic means, okay, so I have a service A that needs to reach to the service B, and if it's not responding, how many times do I need to retry? So I need to code that logic. The other approach is authentication. So if I have a specific way of authentication with the service B, I need to manage that in the code perspective. Last is the other piece is the certificate. So I need to create certificates for each endpoint and then rotate that. So this is going to be a painful task at the end if I do that quite often. Observability is another one, traffic splits, of course, and security, or that we mentioned with the rate limit. So there are plenty of scenarios. So how do we define those policies when we use service mesh? At the end, the advantage is that you only focus on your code and only your code. You don't have to worry about the arrests. And then the service mesh will inject in the, I would say, most common service mesh of the market, a sidecar proxy, and that sidecar proxy will cover all the features that you expect from a service mesh, from a microservices application. So at the end, lower code, smaller containers, and then the rest is managed by another system. So how do we inject those elements in a platform like Gloo Mesh? How does it work, Antonio?
So basically, like nowadays, every single platform, it's divided into the data plane and the control plane. We're going to have like the brain, some operator that is just some certain applications that they are just intended to operate. It's called, for example, if we go to Kubernetes, that is called operator, right? They are intended to operate other. And then we have the data plane. As you explained, the way we do it is basically you need to inject a proxy, because here is, as we are seeing now, it's everything about controlling the traffic, controlling communication. But since we are not part of the applications, because the application is already deployed in a different life cycle, we need to enhance the application behavior with these extra values that you just explained before. So in order to do that, we deploy next to the application the proxy. And that is when the magic happens. Control plane will operate each of the proxies. Advantage of that architecture, if we lose the control plane, our data plane, our business, our services that needs to be in green, they're going to keep being in green until the operator comes back, are being accessible and start working again, so that new changes can be applied. But since we are fine with a stable configuration, if we lose the control plane, our data plane will remain intact. Just a key point here, the patterns that we mentioned before, they are applied to the data plane, because what we want is to have our services resilient, responsive, to fail fast. So those are the configurations that at the end, they're going to be applied in that proxy that we see in this picture. So
what about the Gloo platform? So what is the Gloo platform all about?
So we mentioned here service mesh, and it's lovely, but many people are scared about the service mesh. Service mesh, so far what we see, it's about controlling traffic, having a proxy next to the application. In the past, we can understand that picture with, well, some people they describe it like, wow, but this is just the classic, the forever API gateway, the forever proxy pattern. So in the past, we used to deploy an API gateway at the front of our infrastructure and rely on what is happening inside of our infrastructure. It's like we are inside home, we feel safe. But the reality is, like, somebody can cross the main trust of your house and stay next to you in the next door. So you need to really be protective, not at the level of your house, but at your level of yourself. And that is what comes with the idea about the service mesh. Service mesh is applying security, controlling traffic, observing, having the capabilities and of observing the traffic, not just north-south traffic, API gateway, but also east-west traffic, service mesh. So our platform, in essence, is just, if we are talking about the same, let's use the same tools to do the job. We are not going to have two different components. We are going to have only one, the platform. But to be honest, some people, they want to only deploy an API gateway. You can deploy it on this shape. Some people, they want to be deployed on the service mesh shape. And some others, they just want the two of them. So there are three ways of deploying, but the concept, the way you operate it, the way you manage this platform, is going to be always the same for north-south and for east-west. So why is this about? Because the service mesh, the winner, we can agree here, it's Istio. I cannot give more details. Big companies, they are focusing on Istio. So if the big companies, all of them is like Kubernetes. If everybody's going in the same direction, makes no sense to just deviate to another direction. Just follow people, because probably you're going to be successful. Istio is that winner. And we can see here, Istio has a bit of, let's say, challenges. Challenge number one, when you go multi-cluster, is difficult to handle. Yes, we agree on that. Problem number two is like Istio is very into the journey, into DevOps journey, is very into the end of the journey. But if we recall what are the rules of or the main tasks of DevOps, one of the main points is end-to-end teams. So you're going to have in one team an operator, a developer, a tester, a product owner. The reality in the companies is like not so many companies are at that age of the DevOps journey. They have the platform team and the development team. If we see the resources in Istio that we can see here, in one resource, we are mixing up things that belongs to an operator and things which belongs to a developer. In which repository we deploy this? Into the developers repositories or into the operators repository? So in order to solve this problem, we just develop an API which is persona driven. We create policies that mainly they are oriented to this operator's role. There are certain other APIs, routing. This is what the developer team knows. So they should use these APIs. This doesn't mean that if you are really DevOps end-to-end teams, you can use all of them. But if you are not at that stage, you can split it. So what we can gain from that is, as we can see now in the next screen, in this one, we can see that first, we can embrace easily DevOps, GitOps. GitOps is basically that my source of truth is not going to be a database, it's going to be Git. It's infrastructure as code, everything as code. So everything is developed and stated, fixed in one repository. As we said before, in this end, there are two teams that they are not sharing those repositories. So with the platform, with Gloo Platform, we are able to store the resources intended to be used for those operators into the repository for the operators. And the resources intended to be used for the developers, they're going to be stored into the developer repository. Then we use GitOps tools like Argo, Flags, or whichever other to just keep that state, push that state to the cluster, and make the operator the brain, we mentioned before, the brain management plane to just distribute the configurations in order to configure the proxies and make at the end the magic happen. So one interesting thing about the Gloo platform is just about service mesh. It's not just about that. We mentioned API gateway before. Which are those capabilities? We base everything on experience, listening to our customers. And our customers at the beginning, they claim just for simple things: authorization, authentication, OpenID Connect, Auth2, JOTS. All right, let's put it. But as we were progressing, people were coming with other requests. Well, actually, we have mobile applications oriented. Our system is mobile-based application, and we are using GraphQL. So we need to integrate a GraphQL server like Apollo. So all those capabilities natively injected into the platform. Integrating with Lambda function for serverless, right? We can have it. WOF and rate limiting, like we mentioned before, in order to really protect the consumption of our APIs. And finally, and then probably the most interesting and most important one, since we are nowadays working on the idea about platform engineering, we need actually an internal platform, an internal developer platform to really expose our APIs somebody's going to consume. So automatically, the platform, Gloo Platform, is able to generate this internal developer platform that we can also be used internally, but also externally to monetize the consumption of those APIs. That let's figure that we are an aggregator of APIs. So we monetize the consumption of those APIs. So we actually use Gloo in order to perform rules to be able to monetize the consumption of those APIs through a portal. And I think that we can just end the story about the Gloo platform. Like we go, once anybody start a business, we start small, but at certain point when we are thinking about high availability, when we are talking about disaster recovery, everything nowadays, when we distribute systems, we are on microservices. At certain point, we need to talk about multi-cluster, multi-cloud, multi-region. So the idea about all this is to deploy redundant services, because as we always say, we need to be green. We need our services always to be available. So in order to do that, that is the biggest advantage of the platform. It's going to operate Istio for you. To not be worried about Istio, it's going to reduce the complexity to the minimum, offering that API, so that in this case, for example, as we can see in the screen, if we lose service A in one cluster, the system is smart enough to redirect traffic to a redundant service. So once again, we just become green. That is the final point of all of our business, right?
And the last feature that we discussed was observability. And here, this is where I'm going to jump in for sure. So just to remind observability, if nobody knows exactly what it is observability is the ability to understand precisely a situation. And for that, you need different type of data, different type of signals. So logs, of course, we've been building logs since many years. Events, a system like Kubernetes, or even build systems, generate events, and those are rich information that help us also to understand a given situation or a given release. Metrics, traces is quite popular now. It gives you at least understand where we're spending time, but if there is a problem related to the code, of course, we want to jump into the profiling. So that's all the different signals that we rely to do some observability and understand given situations, but signals without context is not helpful. And what we do at Dynatrace is to be able to contextualize automatically the information that we collect. So then all the information are somehow indexed. And then the value is that we are massaging the data for you. So then it's simple to understand situations. So we add information about the technology, the version, the geo, and so on. And there's plenty of way of doing it. So at the end, when you are dealing with a cluster or any systems, you can deploy either our agent into your environment, or we can also utilize open observability framework of the market like Open Telemetry or Flintbit. And the objective is to basically produce traces, events, metrics, log that I explained before, and that data will come into our platform. And in the platform, we will have all the right features that will make the troubleshooting or understanding or optimization approach much more faster. That's the way of, because on the top of that, we have a common storage called Grail, and you see I'm going to use in the demo lots of things related to Grail with the Dynatrace query language. You can do automation, and we also have the AI on top of that. So plenty of amazing stuff that we are able to do that. In the service mesh side, currently we have an Istio integration that probably going to be improved. But at the moment, it's two dashboards. So we have a control plane vision and data plane vision. And at the end, with this, you understand what's happening in your system. But with the data we collect either from our agents or from Open Telemetry, you can see the application health on the side of your control plane, so and the data plane. So the traces, with the help of traces, metrics, or logs, where from the logs you will see that we can start building also graphs in a very intuitive way. But today, in this webinar, we prepared an environment where we are going to, of course, use Dynatrace as the observability backend, and Gloo Mesh also offer a couple of observability features. So what are those features that you're covering at the moment, Antonio?
That's great. You love Open Telemetry because actually you are part of the project. Huh? So that is probably the most interesting thing. I really love the idea about Open Telemetry. And one of the, as Henrik mentioned, one of the offers to integrate this protocol, this amazing protocol that joins together the signals, the three different signals, the fourth one being the events. So this component, it's the collector, and this is what we use. With our platform, we deploy a collector, and we instrument the proxies to collect logs, traces, and metrics. So we can just drive them through each collector to a gateway. And here, as we can see, what we're going to do is just transport all the signals to Dynatrace, because the platform comes with a UI. But of course, the UI is intended to present things about the platform. But anyhow, we really need to have something more powerful, something fully dedicated for observability. And this, in this case, is Dynatrace. In Dynatrace, as we will see before, After that, we're gonna see dashboards. But before going that direction, how we configure, how works the collector. So the idea is very, very simple. Some information coming in, we need to configure that incoming data. How we call it? Receivers. So we've got the proxy already configured to send the signals to the what we configure in the collector on the line of receivers. Here we see Prometheus and OpenTelemetry protocol. Then we have processors. We need to process the data, right? We can just pass the data. Maybe we have to create batches. We need to make sure that it's not gonna blow, the amount of data is not gonna blow the collector itself. So we need to process that data and we transfer it to a next level. Here, as we can see, we are just driving signals to a final end, a backend. In this case, we drive it to the gateway. And if we move forward to the next one, so we can see that in the gateway, what we're gonna do, we're gonna receive all those signals. Since we grew wild, we have different clusters. We are collecting also from the management cluster all the data, all the signals. Again, putting all together from the receivers, defining receivers, creating some processing. In this case, it's really interesting. We need cumulative delta. That is really important to integrate with Dynatrace. And then the exporters, where we're going to export the data. In this case, Prometheus, because our UI is fed by Prometheus. But as we mentioned before, to really get a huge effect, a huge debugging help, we need a backend as strong as Dynatrace. So we export the data to Dynatrace. And I think that, yeah, we can move to
I think it's time
demo.
to the demo.
Andrew?
Yeah.
So let's do it. Let's show it.
Yeah. So we've prepared this GitHub repo. So we'll share on the screen soon the actual repo itself. But it's stored in my own account, but we can push it somewhere else. But it's Henrik Rexed, Dynatrace-solo.Jedi master of traffic management.git. And everything that we've prepared here will be available and you can utilize it. So at the end, we deploy a demo app. It's going to be Hipster Shop. We simulate some issues on the Hipster Shop. We have the Dynatrace operator deployed. So at the end, Dynatrace is instrumenting the pods, producing traces, collecting logs and everything. And like Antonio explained, we have Gloo Platform deployed. And we use the OpenTelemetry collector and the connection, like Antonio mentioned, it's going to be happening on the gateway collector provided by Gloo Mesh. So that's the technical environment. So let's jump into the actual story. And for this, I need to open my browser. Here it is. Is it the one? Yes, it is. So the first thing here is the repo. So all the instructions are here, so you can follow up. And we will see different things. So in this story here, we mentioned request timeout. We mentioned rate limit. We mentioned traffic circuit breaker, and last we also wanted to introduce the notion of traffic split. So we will just try to cover this in a demo in 15 minutes. So first, let's cover the aspect of the request timeout. And to deliver that, I already implied the rule in my environment, so I won't have to do it. But Antonio, could you explain us the retry time? So the request timeout. So this is the settings that we've been defined in this environment. So what is this going to do in the environment?
So very short, we are defining a host where we're going to apply it, and here the policy, the retry timeout policy. The platform, in order to make it easy to maintain and easy to operate, is just based on policies, different than Istio. And we just define which application, which service we're gonna tie this policy. And as we can see here at the top, we can see that is any service with any route with retry enable. And we're gonna then enable it with a request timeout of 2 seconds.
So what does that mean when it comes to, first of all, when you deploy Gloo Mesh in your environment, you will get the Gloo Platform UI. So this is the Gloo Platform UI that shows you your environment, the cluster and so on. You have a graph showing you the different things. You can filter by namespace and so on. But here What is interesting here, we currently have a policy, so the one that Antonio explained, and you can see the actual policies that are being deployed. So you have a clear vision on the settings that is currently applied.
And
that's one thing.
To the service being applied, yeah, that is an important thing. That helps you to really understand what is being configured in the system. Just one mention here is really important to understand this is read-only UI, because we really believe into the GitOps approach, because we believe that the configuration should be treated like as code always. Why? Because it needs to be reproducible. We need to reproduce scenarios in different environments, and needs to be, of course, portable and testable. In order to do that, we cannot rely on a database. We need to rely on a source trust like whichever Git repository.
So now, what do we have in Dynatrace? So in this particular story, what I have prepared here. So first, I mentioned the dashboard that we provide out of the box from Istio related, because Gloo is managing at the end in a smart way the Istio in the background. So if you go to classic dashboards, it's an app in Dynatrace. If you search for Istio, you will see that we have two dashboards. We have one from the control plane, showing you the health of the control plane. And the second one is the data plane. So data plane will show you, explain the various proxy and what they're doing. So if you go to data plane, you will see that we have different, the volume it's happening and all the different workload that is currently served by this data plane. But then, because I've deployed the Kubernetes operator, what is happening is that, first of all, I have the data of the actual cluster. So I can see the namespaces, the pods, the services. And if I jump, for example, in our case, we know that the service that is under problem, we can pick this one, for example, the front end. And I will see that I have the Kubernetes service. And if I have the Istio integration, I will have extra information provided by the Istio. So I'll have lots of different details provided. You can see we have the events and the logs. But in this particular case of the scenario, what I decided to prepare is a dashboard related to Gloo for this specific situation to highlight a different use case, the one with the request timeout, the rate limit, the circuit breaker. How do I define that we have those situations? And to do this, I am doing DQL, so Dynatrace query language. And there is if you want to debug your own Dynatrace query language, there is a notebook. And you will see that the various queries that I did for these dashboards are mainly sometimes relying on logs. You can see here, the main advantage is that I'm collecting the logs provided by Gloo, the Gloo platform, and then I'm parsing that log. And then from the moment I parse the log, I can then attach it to different entities in Dynatrace, filter, and do any aggregation of calculations. So let's jump into the dashboard. So I would just want to briefly explain technically how these dashboards have been built. You can see here, the first thing I try to show here is the actual CPU usage of the Istio proxy container. So I can see at the moment all the workload having the Istio proxy container. So that's just a way of how in terms of resources, if I'm consuming too much or not. And then here, in the case of the request timeout, so this policy has been applied, and you can see that the graph is currently showing us that we have a lot of requests under timeout, and we see that it's the product catalog. I mean, as expected, because it's the demo. One thing that I decided to do, side of that, before we jump to the other scenarios, is to include automation. In Dynatrace, we have the data, we can send you alerts, but you can also be creative by doing your own workflows. So here, for this, for today's webinar, what we've decided is that, hey, let's do a workflow. So here I've defined a workflow where I run every 10 minutes. I could have imagine another way of triggering that event based on that workflow based on an event. For example, we have an alert that I've been raising, then I want to trigger that workflow. And in this particular case, it's a cron based, so it's going to be every 10 minutes. I will execute that cron job, and then he will execute the query I did, and then he will send some Slack message. I could have imagined to do some PR request or anything. So let me open Slack. I think when we started the webinar, yep.
I really like this. I see a lot of potential on creating triggers in order that at the instance of an event, I'm going to be reactive, like, for example, reoperating, reconfiguring the platform to behave differently based on the metrics that I received. This is really interesting.
So here, in my case here, so this happens at 4:40. So that was 6 minutes ago. So I had a notification from Slack, from the workflow, saying that on the last 10 minutes, we had some requests under timeout on this cluster, this namespace, and this is the workload. And during that time frame, we had 21,000 requests that was in timeout. So it's quite a lot. So this is running every 5 minutes. You can see that I'm receiving a lot of alerts, but again, I was preparing some data. So this is just a way of showing you that you can do tons of automation. There's a second use case. So let me deploy the second use case, and we'll let you present the second use case, which is the rate limit. And in parallel, I will deploy the actual scenario. So what did you do in terms of configuration?
So when we deploy the rate limit, basically, again, it's just a policy where we just select which applications are going to be tied to this policy across all your clusters. These configurations, they work for all your clusters to the region, that the space that you are reserved. So each team, they're going to have their own workspace. So inside all that workspace across multiple clusters, I apply this configuration, and the configuration will be applied internally. As we can see here, it's as simple as defining a counter with a key, and then we use that just that key to define the number, which is, I think that I configure it to 100. Is it possible if you scroll down a bit?
Yeah, 100 per minute.
Yeah, 100, as we mentioned before in the presentation, 100 requests. So it's obviously that an attacker running more than 100 per minute is going to be blocked.
And while Antonio was talking, I applied this rule. So now, if you go back to the Gloo Mesh UI, you can see that in the policies currently deployed, we have the rate limit policy created. So now we know that it's currently happening, and the other one, the other policy, the request timeout, has been removed. So in the case of Dynatrace, same thing. What I did here. So let me, because I did a lot of tests. So let me 2 hours. I've created similar dashboards, and it's very hard to see here. But here, normally we'll see here, if we in this time frame, we have some rate limit request in rate limit, so we can follow that through this indicator. So same thing, if you want to check this metric, I've put that every description in the repo. But again, I'm relying on logs, and I'm counting all the access logs that are rate limited. And this has been basically displayed here. So this is a way of checking it. And similar to the request timeout scenario, we can also think about notifying or creating automation actions with utilizing workflow that I just presented a few minutes ago again. The other scenario we wanted to cover was the traffic, the circuit breaker, I think, if I'm not wrong.
Yeah, that's right.
All right, so while I will let you present it once I deploy the new rule. Oh, where is my UI? Here. So this comes in 2 files, I guess. So we have the connection policy.
Because basically circuit breaker is based on different patterns, and one is like you can configure the connection policy to define how big is going to be the connection pool. In this case, we're going to shrink it only to 1 connection per time, and as we can see, pending requests. These are like, just imagine again, A, B, and C. If C fails, A, the beginning, is going to stay waiting. So that is really like the incoming requests that are going to be piled into a pending state. What we want is like, we are not going to wait. We're going to just cut all these connections and return the error to be handled by the client. This is what we're going to do here. And in the other one, what we are going to do, which is that layer, as we mentioned before, we set up some type of health checks, smart health checks, to define if actually a replica it's actually available or not. from the client perspective, from the person who's calling. I can reach all the replicas? No, so please mark one. So when the request comes, we are not going in that direction. That is what we configure here. We're gonna define some retries because maybe there are failures in the network and we need to retry it. And then finally, to define the time that there's gonna be evicted. So try, if it fails, wait 30 seconds, mark it as a down, and then wait 30 seconds to try again and verify if it's available again.
And again, here you can see that the Gloo platform picked up the new settings because it's basically showing us the actual policies. And again, from a Dynatrace perspective, I did the same thing. Here I have another type of KPI that I use. So there are metrics that is exposed by the Gloo Mesh and Istio related to that specific scenarios, or you can also rely on logs. I decided to use logs because at the end, every single request comes as an access into as an access log. So you can basically do some statistics on the top of that. Looking at the time, we have 9 minutes left. So I think let's not cover specifically the traffic split. Let's I'm just going to conclude this demo. Just to add from the observability standpoint, here I have created a specific dashboard showing you the versions. And if you do, in this case, you can see that we have 2 products up. I can remove the various other services, but I can count the product catalog version 2 versus the version 1. So if you do traffic splits, you can also see that into a graph and compare how many traffic is coming in, with the help of a traffic split. Traffic split, again, we didn't cover it, but traffic split allow you to have 2 versions and manage the weight. So 20% of traffic on V1 and 80% on V2, or the opposite, for example. The last graph that I introduced here is the latency in the Envoy proxy. So I measure the time spent in microseconds in incoming traffic and outgoing traffic. And I can see the various roles. So usually this is cart service to cart service, which is local. But also you can have the outbound. So checkout services calling the email service, how long it took. So you can basically, if you know what data comes in, you can start doing amazing visualizations. And as a conclusion, as in the repo, I have added the DQLs that you want, if you want to run those. Here it is. And we also have in the repo a Dynatrace folder. And in that Dynatrace folder, you have a JSON, it's the export of the Gloo Mesh dashboard that I just showed you a few minutes ago. All right. So as a takeaway, first of all, in Kubernetes, in general, I would say define properly your resource to avoid this OM kill or avoid CPU throttling. Define resource quota on your namespace, specifically of different services. On the service mesh side, I would say we covered that you can have major production incidents due to basic stuff. By putting some service mesh rules like rate limit, circuit breaker, request timeout, you are protecting yourself. Again, you have to manage the error when they are arriving, but at least it's a way of to increase the reliability of your systems and of your applications. And again, this is only possible if you have observability. So collecting metrics, traces, log, profiling is crucial. Define metrics based on logs that I did is also a smart way. Automating alerting, automating creation through workflow is also a smart way of doing this. Do you have anything to add, Antonio, on your end?
Future of this, just imagine we are heading to Internet of Things. The computing is going to be everywhere. The computing is going to happen everywhere. Somebody needs to handle the traffic of that. And that is going to be the mesh. That is the only way to go. It's the only thing I have to say. I'm always thinking about that. I'm really a lover of the mesh approach. So I really believe this is the way to go. Lovely. I love these pictures.
So a small promotion on my end. So this is observable. It's out there. So yeah, check it out. I did some episode on service mesh, on ambient mesh, on the API gateway. It's there. Again, to improve the content and your feedback. So if you like it, just say it. If you don't like it, you can also say it. And it will be a way for me to improve the content. All right, so I think we covered
there is a question from a user that they are asking for the SaaS model. If actually, I think that they can reuse the JSON that is in the repository.
So it's a question. I'm using SaaS, Mark. So it's a question from Mark. So we are using on-prem. Okay? The good question, Mark, from your end. The only problem is that this specific JSON is for the new Dynatrace. So if you use on-premise, I don't know if you have the new UI yet or not, but you need you need Grail at the end. That's one of the key thing, because here I'm using the new way of querying the metrics and the new way of querying the logs. So I don't know if you would be able to achieve the same representation. We did in the repo on the README file, we did listed some metrics that could also make sense to visualize the request timeout and the circuit breaker and others. So you can still rely on those if you're still running on the on-premise version of Dynatrace. Yeah, it looks differently. I know. I would say it's honestly, this new UI, I mean, the platform, we call it the platform, allow you to open doors to lots of new things, automation with the workflow. You can also build your own apps. So it's very exciting to move to that direction. I didn't show you the notebooks, but notebooks is a crazy feature where I can basically run query and store it locally, so then I can still look at the results, even if I'm not connected anymore to the environment. And and then it's a way of querying your spans, querying your logs, querying your metrics. So it's very powerful for sure.
I like this UI, yeah, definitely.
Is there any other questions from the attendees?
So just on my side, I just want to say, guys, if you want to reach out in Slack, you can go through Dynatrace as well on Solo. We are in the public Slack, fully reachable. Also LinkedIn, you can reach out to us for any questions regarding service mesh and observability and how to combine them together, how to configure collector, which is it's simple, but well, like always happen, YAMLs is very easy to make a mistake in the YAML. So yes, reach out to us, whichever question or help. We will be happy to help.
Sure. And again, I'll leave the GitHub repo if you want to take advantage of this. So it's out there. Make sure to use it because we spent time to build it, and it was quite fun, to be honest. So just use it. It's out there to try it out and enjoy.
May I tell them, Henrik? Like Henrik had the idea, like why not we build like a real workshop based on this for everybody just to go and try. So internally, we are actually talking about just creating a workshop dedicated to these kind of features. So that would be quite interesting for everybody to try, not just the demo, but in a workshop shape.
That would be amazing.
Yeah, that would be great. Yeah, there are more questions maybe?
It's for people who are working. Yeah, so yeah, it's Mark has a comment about the features, but yeah, we try to deliver a lot of features. And we try to make it them to promote those features. But yeah, it's true, if you're in the middle, we a lot of work on your shoulder, it's very hard to see those features coming. But yeah, we have a very regular pace of releasing new features. So but yeah, look at the new platform, you will see that you can do tons of things. All right, so I think we reached the top of the hour. So thanks, Antonio. It was great to prepare that event with you.
Thank you, Henrik. It was a really pleasure. You are great. I love it.
Thanks. All right, so thank you, everyone. Enjoy your end of the rest of the day, and thank you for staying here 1 hour with us. So see you soon for another webinar or another event.
Thank you. Ciao, ciao, guys.